Before we jump into data structures and algorithms, we have to talk a little bit about the big O notation, which is very interesting topic and that is very important for your career as a developer. Everyone that enter the programming world should understand this and should keep in mind while programming this concept, the big O notation. Big O notation means the efficiency of your algorithm. If I told you to go and look for the meaning of this word, pigeonhole, in your dictionary, not on Google, don't translate it on Google, just go to your book, normal dictionary, and find the meaning of that. I hope you have if you have one. Well, probably you will go open that dictionary and you start. This is the first algorithm. It's an algorithm, right? We start page by page. 1, 2, 3, 4, blah blah blah, until we find that page that contains this word. Well, that's an algorithm, right? We go page by page. What if you go to the index? That's what you normally will do. You go to the index and you see where is the P starts from, which page, and then you open the P directly, right? So imagine how much time you saved by changing the steps of your algorithm. Instead of going page by page, you jump directly to the section of P, and that's what we normally do. We don't go page by page, right? And that change in algorithm increase the efficiency of searching in that dictionary and finding the meaning of that word. And if you don't know what is this, it's basically the box of the pigeon that lives inside. Okay, so that's another point. All right, so I hope now you are clear with me. What is the difference between algorithm A of going page by page and algorithm B, which is going directly to the section of P letter to start searching from that? We save tons of pages, tons of time searching for unnecessary data. And if we can go faster, we can break that to be, okay, we know that P is this section, let's say starts from 200 number page. And then we know I is somewhere in the middle, so we can cross reference and see, go directly to the middle of the P section, and then we can look that faster. That is a very fast and efficient algorithm that we can take. Similarly, in computer science, for a specific problem, we could have different solutions, and not all of them could be efficient. One of them might be very slow, one of them might be very fast. So big O notation is a consideration of how fast and how efficient your algorithm is. So if we go to the same example, we have pages. Each page will contains different words, and if we look one by one, we call it linear algorithm. That means if we have a dictionary with 2,000 pages, right, or 5,000 pages, it's a very big dictionary, and this pigeonhole lives on the, let's say, 2,540 page, the number of the page, then we have to spend 2,540 pages looking for that word before we reach that, and that's very slow. Additionally, on the other hand, we can go with directly to that page, or probably near to it, probably 2,500, and by doing so, we saved at least 2,500 pages looking for the unnecessary data, and that's very fast. So ON or O1, that means we could, if the optimal case in this example is if we go directly immediately to that page, that's the optimal one, or the ideal solution is to go directly to the page. Now probably you have that in your mind, probably you're studying from a book and you have that label. You can label a specific page where you left reading, and then when you come back, you know exactly where's the label. You open that and you go directly to the page, right? That is O1. It's directly to the page. But if you don't have that label, that strip that indicates which page you left from, it's hard to go back and see which page you left from. You have to go back either reading page by page until you find the page you left from, or doing some smart algorithm to find the page, right? So the ideal solution is to have the page directly, which is O1, and then we have different levels of efficiency, decreasing in efficiency in computer science. So this is the optimal or ideal. And then we have probably ON efficiency to look for. We have N log N. We have N factorial and many more that I really recommend you to look after and see the differences between them. So keep that in mind. Not all your solutions will be efficient, but always try to improve your solution to the optimal case, to the ideal case. If it's not possible, then get at least to the nearest of it.